The last two chapters that we're going to be working on in this advanced chemistry course are modules 12 and 13 on organic chemistry. Now, if you are my student and you just finished module 11 and you thought we were going to start module 12 next, and you've popped up this video before you've looked at the materials I sent you, you're going to want to go back and look at things again, because you should have gone from module 11 to module 14 and then back to module 12. And the reason I did that is because if you're taking the AP exam, the information that we're covering on modules 12 and 13 is not really on the AP exam. So I wanted to make sure that you had everything you needed for the AP exam first. So that's why we saved modules 12 and 13 for the very end of the year. They are on organic chemistry. And if you decide that you're going to go to college and you're going to go to med school or vet school, or if you're going to major in chemistry or you're going into some of the other sciences, you will be taking organic chemistry, and you'll have a whole year of organic chemistry. Normally that's taken your sophomore year. You might not take it till your junior year, but you'll have a whole year of chemistry first, and then you'll go into a year of organic chemistry. Organic chemistry is all about carbon-containing compounds. And an organic compound does not contain any metals. And there are several different classes of organic compounds. And in the next two modules, we're going to hit several of those different classes of compounds. But we're going to start with the most simple, which is called a saturated hydrocarbon. Now, if you look at the name hydrocarbon, you can probably see two pieces in it. You can see carbon, which is what I said, it's a carbon-containing compound, and then hydro, which is where the hydrogen is. A saturated hydrocarbon, you've probably heard the term saturated before, but you've probably heard it in terms of saturated fats and unsaturated fats, and that's because the carbon chains in those fats are either saturated hydrocarbons or unsaturated hydrocarbons. So a saturated hydrocarbon just means that it is containing as many hydrogens as possible. And what that means is that there's no double or triple bonds involved in these molecules. So there are two different types. You can either have what's called an alkane, or you can have a cycloalkane. And as means of illustration, I'm going to start with a 4-carbon containing compound. And so if I had 4 carbons and I strung them together just in a straight line like that, and then I went through, again, all single bonds, no double or triple bonds. If I went through and added as many hydrogens as I could possibly add, each carbon is going to have 4 total bonds. And so therefore, I'm just going to go in and fill up all these spots with hydrogens. Okay, so as you can see, this is going to have 4 carbons and 4, 8, 9, 10 hydrogens. And so the overall general formula for an alkane is going to be C, and however many hydrogens you have, you're going to have that number times 2 plus 2 more. And you can see that because each one of these has a hydrogen on the top and the bottom, and then there's 2 more on the end. Okay, so that's the general formula for an alkane. Now, if I put them in a ring instead, in a cyclo compound, so if I take those same 4 carbons, only this time I'm going to put them in a ring, now how many hydrogens can I attach? Well, I can still only attach 2 hydrogens to each one, because each carbon can still only have 4. Okay, so at that point, now I'm going to have C4H8. And so the general overall formula, because this same pattern is going to be true no matter how many carbons I have, the general formula for that is going to be CnH2n. So if you had 5 carbons and you had them in a ring, you would have 10 hydrogens. If you put them in a straight line and you had 5 carbons, then you would have 2 times 5 is 10, plus 2 more is 12. So it would be C5H12 for your general formula. And that's going to work, again, no matter how many carbons that you have. Now, you can also have what are called structural isomers, which what that means is that you have the same chemical formula, but you can rearrange those in slightly different ways. So if I take this and I'm going to make structural isomers for it of C4H10, these are all in a straight line. So I could take 3 carbons and put them in a row, and then I could take another carbon down off the bottom that way. So now they're in a T shape, and then I can still go back in and I can add all my hydrogens. So 3 there, 3 there, 3 over here, which makes 9, and then 1 more makes 10. So it's still C4H10, but I just have it arranged in a little bit different way, okay? Now, when you're drawing structural isomers, you need to be careful that you don't accidentally draw the same one twice. So would it be a structural isomer if I did this? If I put 3 in a row and then I took this carbon and stuck it up here on the top? No, that's not a structural isomer, because when you have these bonds, they can actually rotate. So if you kind of picture if you had like some Tinker Toys or something that you were playing with, and you grabbed a hold of this end of it, you could actually take this and you could rotate it around so that it's, you know, it's on the bottom, it's sticking in the front, it's sticking in the back. It'll rotate around 100 or 360 degrees. So those bonds rotate. So what you have to look at is, where did you attach the carbon? It's still attached. This one is still attached to the second one in the line. So that's why this and this are not structural isomers. They're exactly the same molecule. So those are the same. So for C4H10, there are only 2 structural isomers for that. Now, the other thing that I want to show you here is that this, as you can imagine, gets very cumbersome to draw it all out. And so we have come up with a couple of different shortcuts for how we can explain what these look like. So for this one, I could write CH3, CH2, CH2, whoops, got a little carried away there, CH3, okay? So hopefully you can see where that comes from. 3 here, CH2, 2 hydrogens on that one, CH2 here, CH3, 3 hydrogens on that one. Now, just because I write it this way does not mean that it's the hydrogens that's attached to the carbon. It's still the carbons that are linked together. But this is how we write that shortcut for it, okay? If I'm going to write the shortcut for this one, what I'm going to do is I'm going to write CH3, and then I have a CH, and the way I show that this one is hanging off of this one is I put it in parentheses, CH3, and then I have another CH3, okay? So the ones here are your main chain, and if this one's hanging off of something in the main chain, you're going to put it in parentheses after the carbon that it's hanging off of, okay? So just another way to write that. There's even yet another way to write that, to really make a shortcut, and I can actually just draw line figures that look like this. This means the same thing as this, which means the same thing as this. And the way you read this is that every time you have an end of a line segment, there's a carbon on it. So I have a carbon here, that's 1. Here's the second one, here's the third one, here's the fourth one. So 4 carbons. They're all single lines, which means that they're all single bonds. And so as long as you go 1, 2, 3, 4, you know that it's a 4-carbon chain and it's a saturated hydrocarbon, because I'm not showing any kind of multiple bonds in there. And it's assumed that you're smart enough to figure out that that carbon on the end is going to have 3 hydrogens attached. This one's going to have 2. It's assumed that you can figure that out. If I wanted to write this one with the same kind of notation, I would have 3 in a chain, and then I've got another one hanging off. Okay, so carbon here, carbon here, carbon here, carbon down here. Okay, so you're going to need to learn to be able to read all 3 types of diagrams for these different compounds. Okay, if I wanted to do it in a cyclo pattern, I would do the same thing. So if I wanted to draw this kind of diagram for this, it's just simply going to look like that. Okay, carbon, 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 and then the hydrogens are going to be sticking off the sides. Okay, if you do that, that means you've got another carbon hanging off of it. So if you're going to draw just the stick figure, make sure you don't try to stick hydrogens on that way. You're just going to do that with more carbons that are going to be hanging off of it. Okay, so 3 different ways to draw these structures. Structural isomers, again, as you're drawing them, be sure that you haven't inadvertently drawn the same structure just by flipping its location. The best way to be able to tell, and we'll talk about this a lot more tomorrow when we start naming some of these compounds, is if you put your pencil on it and you can keep drawing a straight line through it, that's going to be your longest chain. Here, if I can draw a straight line through it, this is the second carbon, and so this is hanging off of it no matter if I put it on the bottom or on the top. Same thing here too, if I would do carbon, 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 and then put the 4th carbon on the top. It's still the same structure as this one because all 4 of those carbons, I can put my pencil on it and keep drawing a straight line and go through all of them. I'm sorry, I pointed to the wrong one. This structure is the same as this structure, okay? Because I can put my pencil here and draw a straight line through. I can put my pencil here and draw a straight line through all 4. So these 2 structures are also the same, okay? So again, as you're drawing those structural isomers, you just want to be sure that you don't draw too many and you actually have some of them repeated, okay? So there's our first introduction to organic chemistry.